In this video, we're going to be looking at a specific type of addition reaction, specifically hydrogenation. But remember, you also get halogenation, hydrohalogenation, and we get hydration addition reactions. I've chosen to split these videos because it makes it a lot easier for me, especially because I make a lot of mistakes, and also it will assist you if you need to take breaks in between. But at the end of the set of videos on addition reactions, you will be able to complete exercise 12, which is on page 123 and 124. So only the section 1, which is on addition reactions, you'll be able to complete from exercise 12. There are other sections that will come up after I explain the different types of elimination reactions and substitution reactions. So in this video, we're taking a look at the addition reaction called hydrogenation. So from the word hydrogenation, you should be able to identify the word hydrogen. And this is because a hydrogenation reaction is where we have the addition, we are adding hydrogen to an alkene, which is our unsaturated substance, our unsaturated organic compound. In this case, our unsaturated compound is specifically a hydrocarbon to which we are going to be adding H2 gas, or in other words, hydrogen gas. Now, grade 12s, you need to be able to identify these reactions as hydrogenation and as addition reactions. And there are some reaction conditions that you need to know off by heart. So when we have a hydrogenation reaction taking place, the alkene should be dissolved in a non-polar solvent. You don't need to know this off by heart, but it's very good if you choose to go into the sciences and have to perform some experiment involving hydrogenation. What is important for you to know off by heart is that we need a catalyst present, specifically a catalyst such as platinum, palladium, or nickel. You need to learn this off by heart. Most learners choose to just learn one of the catalysts, which is sufficient, and they choose to learn platinum. So you can do exactly the same, but just remember platinum, nickel, cobalt. And if we then give you the reaction, instead of asking you to write out the reaction, if you see one of these, then you might be able to identify or think that it's possibly a hydrogenation reaction. Now, just for interest sake as well, the hydrogen gas is going to be bubbled into the container so that it can interact with the alkene that is dissolved in that non-polar solvent. And what's also important, but not important to know off by heart, is that no water must be present during this reaction. Because if there is water present, we are not going to have a hydrogenation reaction taking place. Instead, we are going to have a hydration reaction taking place. So the general reaction for a hydrogenation reaction is an alkene reacts with hydrogen. Hydrogen is a diatomic molecule, and therefore it's always going to be H2 to form an alkane. The way you're going to remember that this is an addition reaction is we have an unsaturated substance becoming saturated, and based on the acronym USA, we know this is an addition reaction. So hydrogenation here, this specific type, is going to be an addition reaction. So here's an example that has been taken from your textbook. We have ethene reacts with hydrogen to form ethane. And notice we write our important reaction conditions above the arrow. Normally we ask you to write out the structural formula, so the structural formula reaction, because we want to test your ability to write out the reaction, but also see if you can draw structural formulas. Here, however, they've included an equation involving the molecular formulas as well. And I'm not saying that they can't ask this, but it's not often asked in molecular formula form. But they can, and sometimes they will. So grade 12, you need to be able to perform these or to identify them regardless of how they write out the formulae or regardless of how they ask you to write out the formulae. You need to know the different types of formulae that we use in organic chemistry. So each bond you need to see as two people holding hands. Here our hydrogen holds hands with the carbon. Hydrogen holds hands with carbon. Hydrogen holds hands with carbon, hydrogen, carbon. In the center, we have carbon holding hands with carbon and carbon holding hands with carbon to form this double bond. So if I draw it specifically looking at our double bond in the center, we could draw it like this. We have carbon. Well, you can't draw it like this in an exam, but just to explain this to you properly. We have our carbon bonded to the hydrogen atoms. At the center, we have one bond. And then we have another bond, which, like I've said, is like two people that are holding hands, okay, to form one bond. Then what is going to happen is this is going to react with our H2, which is also like two people holding hands, okay, because we have a single bond. All right, so that's a single bond. And what will happen in the presence of a catalyst is that this double bond, one of the double bonds, is going to be broken, and this bond separating or in between the hydrogens will be broken as well. So that one hydrogen will bond with the one carbon, and the other hydrogen is going to bond with the other carbon. And then in the end, where that double bond would be, the one bond will lead to the formation of ethane. Okay, so these two hydrogen atoms are going to take the place. One's going to attach there, or the other side. Let's draw it like this instead. So we are going to have this one over here is going to attach itself there, and then this one over here is going to attach itself there. And then in the end, we are going to have the C, single bond C, the original hydrogen atoms that were there. But from this then, we're going to have one hydrogen there and another one over there. And in the end, we only have one type of compound. Okay, this here is a hydrogenation reaction. Our double bond is broken so that hydrogen can bond to ethene in order to form a saturated hydrocarbon called ethane. And that is the end of this video.